Critical number problem set number 2 is going to be a little more difficult than the first one, as it should be because that was kind of a warm-up, a gimme. And now we're looking at the real thing here. I don't think there's a great way to factor the denominator here, so I went ahead and wrote the problem out because we are here to find the derivative. Critical numbers are when the derivative is 0, so you kind of need the derivative. And what is this? This is a function divided by a function, so that's the quotient rule. U prime v minus v prime u over v squared. We've done a bunch of these. So what's u prime? In this case, they're using the letter y, but that's not the usual y. That's a function of x. Y is our input of the function, so we just take the normal derivative. What's the derivative of y? It's 1. And v is y squared minus y plus 1. It's going to be minus v prime, which is 2y minus 1 times u, which is y minus 1, divided by v squared. So y squared minus y plus 1 squared. Well, I'm already hating this. I get the feeling that I'm going to have to work a lot of this out. So let's just write it out real fast. Y squared minus y plus 1 minus 2y squared minus 2y minus y plus 1. And that's all divided by, well, let's just work out the FOIL here. I got to write it out to be able to do it correctly when there's 9 effing inputs for it. So that'd be y to the, well, let's just keep it written that way, I guess, for now. Y squared minus y plus 1 squared. And I'll show you why in a minute. I'll show you why I did that in a minute. Y squared minus 2y squared, so it'd be a negative y squared minus y minus negative 2y. That's a plus 3y plus a y is a plus 4y. This should be a plus 3 minus 1 should be a minus 2y. Almost did that wrong. Plus 2y. It's a plus 2y and a plus 1 and a minus 1. Okay, so it's just that on top. And we have a y squared minus y plus 1 squared on bottom. So if we factor, we can take a y out and we'll get a negative y plus 2. That's all over that denominator. And the reason that I didn't expand the denominator is that we are going to set this equal to 0. And 0 divided by anything except 0 is 0. So I'm not really worried about this so long as there's no domain problem where it becomes undefined and you're dividing by 0. So all I care about is this numerator here. So of course this y, you can just say y equals 0 would make this whole thing 0. Or this one, you would say negative y plus 2 equals 0. So of course that's going to be y is equal to 2. So our critical numbers are 0 and 2 for this valued function. Does that make sense? You're really worried about the numerator because we're setting the derivative to 0. As long as the 0 is in the numerator, you're going to get 0. Okay, let's move on to problem number 2. Let's write this baby out. H of t equals t to the 3/4 minus 2t to the 1/4. So h prime of t, no matter what we see, it's going to be take the derivative, set it to 0. So we get 3/4 t to the negative 1/4 minus 1/2 t to the negative 3/4. That makes sense to me. Can we take, let's factor this. We can factor this. Let's take a t to the negative 3/4 out. We'll just do the math there. And we would get, well, it would be 3/4 t to the 1/2 because we're adding 3/4 when we take this out. Remember, when these add together, you got to get negative 1/4. So this is a, an algebra exponent thing and a fraction thing. I guess if you're bad at your fractions, you're in trouble. Minus 1/2 because we took this right out of there. Now, why would I do that? Because we're setting it to 0. And this means t could be equal to 0. If I could factor anything out, no matter what its exponent, it could still make a 0. And then this one, well, we get 3/4 times the square root of t minus 1/2 equals 0. So of course we're going to add that over. We can just write it that way now. Equals 1/2. Times 4, divide by 3, so we get the square root of 4. Square root of t is going to equal 2/3. As we get 4 over 6 there, we reduce it to 2/3. Let's square each side like that. You get t equals 4/9. So here's our two critical numbers for that function. I know I did that quickly, but here's the secret. Anytime you have the t's in everything, even if it's a weird one, you can still factor it out, and that gives you a t equals 0 as one of your critical numbers. So this is an algebra test as much as it is a calculus test. I told you guys, my students fail because they're bad at algebra. There's no such thing as being good enough at algebra. That stuff is magic. It's magic. Okay, let's do the third one. I'm just going to use a regular f of x. I don't know why they didn't. X to the 4/5 times x minus 4 squared. What's the process for a critical number? Take the derivative, set it to 0. F prime of x equals what? This is a product rule. U prime v plus v prime u. Okay, let's work it out. What's u prime? 4/5 x to the negative 1/5. V, x minus 4 squared, plus v prime, 2 times x minus 4, and then the chain rule doesn't really apply there, so we'll just leave it like that. And u, x to the 4/5. Is this what you got for your chain rule? This is what I got for my chain rule. Now, how do I go from here? How do I go from here? I set it to 0. We know this. What can we take out of here? It's certainly not pretty. This guy here, that's going to be, and this guy here, we're going to know right away if we set this all to 0. What can we work out of this? Can we work it out of this? This seems very hard. This seems very hard. Here's what I do see. X minus 4 and x minus 4. So if x equals 4, you're going to get 0 here and 0 here. So that's going to be one of them. And if x is 0 here and 0 here, everything's going to work out to be 0. So x equals 0. I don't know if that's going to be all of them. I'm definitely seeing x equals 4 and x equals 0 being part of this, but I believe that if you were to actually work this out, we're going to find it's worse. So let's take an x to the negative 1/5 out and see what happens. We're exploring new territory here, people. That'd be 4/5, and this is an x minus 4 squared still, plus x to the negative 1/5 times, I'll just write 2x minus 8 to make that simple. And then a negative 1/5 being taken out of this makes it a regular x. So again, that's an x equals 0 thing is still true there. So what do we have now if we set this to 0? Let's divide this out, and he's just gone. So we get a 4/5 x squared minus 8x plus 16 plus 2x squared minus 8x equals 0. Let's get rid of this 4/5 here. Can we even? Maybe we can't. 4x squared minus 32x plus 64 over 5. Let's put the whole thing over 5. Plus 10x squared minus 40x equals 0. Let's combine some of these. So I see a 14x squared. Negative 32x and negative 40x would give us negative 72x. And then we get a plus 64. Multiply everything by 5. This is just going to continue to be 0. So what's our factor here? I don't know what the factor is. I'm just going to divide by 2 and see what happens. 7x squared minus 36x plus 32 equals 0. Can 7 come out of any of these? I don't think so. So we're going to need a quadratic equation here. Negative b plus or minus the square root of b squared minus 4ac over 2a. See how many times we're going to be using the quadratic formula in calculus? It's not a joke. So we get 36 plus or minus, I don't know what 36 squared would be. I think it's 1296. But don't quote me on that. I'm kind of stretching the limits of my brain here. Minus 4 times 7 is 28 times 32. That is, let's see, 7 is 8 and 896, I want to say, divided by 14. Okay, so what's 1296 minus 896? That's 400 even, so 36 plus or minus 20 over 14. We're getting warmer. Let's divide everything by 2 again. 36 divided by 2 is 18, plus or minus 10 over 7. So we get 18, that would be, let's just do the math, 28 over 7 and 8 over 7 are our other two critical numbers. So there are 4 actual critical numbers. And I'm not sure if both of them apply, but this is probably the answer to this question. Yeah. That is a harder one. I think you would be expected to find the 0 and 4s. I don't know if you would be expected to actually work out the math on a test or something like that, but this is all about doing the process and trying to find the answer. Let's move on to problem set number 3. You know what? Before I do that, this is equal to 4. We already found that, so it's going to be critical numbers 0, 4, and 8/7. Those are going to be our 3 critical numbers for this one. Now we can move on to problem set number 3.